Hello, everyone. Welcome to our fourth AI Talks in Healthcare. And every week we are inviting speakers from different backgrounds. And we really enjoy to hear from everybody's point of view, new areas, new trends. And I hope you also benefit from it. I can tell you that most our audience from our meetup groups, we have around 5 meetup groups around the US and over 8,000 members. And you can join those meetup groups to get the, I think, more real-time event information. And you can also go to Magnimind website and register email list. And our meetup group, mostly 60% of them is data scientists in different levels, different areas. And a lot of them are interested in learning about healthcare. That's where demand was, and we started that meetings. But not only data scientists we are getting now, we are getting a lot of people from healthcare space. And I was telling intersection between healthcare and AI. I can maybe say maybe merging of AI and healthcare. We can discuss about that term, how that works out. So we've been we are broadcasting this event in 6 different channels, in YouTube, Facebook, and other channels. But we are getting actually most questions from Zoom. And if you have questions, you may still write in those channels. Our friends who's going to collect them, put in the Zoom channel, our speakers will be able to see. And I'd like to also thank our team who's done great effort to put together those event series, including NS, April, Thomas, and Hussein. There are 4 people working behind that. I appreciate their work. And we are getting people from all around the world. We see sometimes hi and hellos from different parts of the world. We always welcome such highs and hellos. You can always say from even California, even Palo Alto if you are here. And yeah, I'd like to just first ask Chirag and Ryan make introduction. I will introduce Jayant after that. So our regular host. Okay, Ryan, can we start with you?
Of course, yeah. So I'm Ryan Spitler. I direct the Precision Health and Integrated Diagnostics Center at Stanford, as well as the Canary Center for Early Cancer Detection. So we do a lot of different types of continuous health monitoring approaches, getting a lot of data, and looking at kind of characterizing the biomarkers, look at the transition from health to disease. So our kind of main mantra is kind of keep people healthy as long as possible instead of waiting till they get sick, or it's sometimes too late.
My name is Shrek Patel. I'm a clinical assistant professor in the departments of neurology and radiology. I was a postdoc at Stanford previously with both Murat and Ryan. That's how we met initially. Now my clinical focus is in patients with cancers of the brain and spinal cord, and in the lab we're focusing on glioblastoma, the most lethal form of primary brain cancer, and trying to develop better therapies against it, as well as understand what the images, brain MRI scans of patients with glioblastoma can tell us about their future for recurrence or even treatment response.
Thank you for introduction. This time I really gave you a chance to introduce yourself, not to bias, but to make bias for your own introduction. That was good. So, but I will introduce Jayant because he has a lot of background as you guys, and I will just go through that. He is a Senior Director AI and ML Engineering and Change Healthcare. And he has a passion in AI, machine learning, cloud native architecture at scale. And he worked in several companies. He has different experiences for each one: Veritas, GE, Oracle, AT&T, and other startups building platforms. So he has more than 15 patents in IoT and NLP processing cloud architectures, which I'm really interested in learn about. And he is given several speeches, and he's been a writer contributing in many areas, conferences and meetups. and he transitioned to, I will say transition. I don't know if he has done AI healthcare before. And as I would like to ask him introduce himself more, that I miss a lot of points, definitely. And he can then tell about how he came into healthcare. Just let's start with that, and how he views healthcare AI compared to all work he done before.
Oh yeah, thank you, Murat, for a nice intro. Yeah, this is my first foray into healthcare. To be honest, like I worked on life sciences, and at GE I also worked on the imaging side of the healthcare. So this is the first time I'm working on patient records, so and other things. So it's a pretty fascinating field in my opinion, because Change Healthcare is in an interesting spot as well, because we are a network which process all the claims. Like we are a network between the payers and the providers, like providers such as your hospitals, laboratories, dental clinics, and other providers. And we process the claim. So once you go to the hospital, you do some procedure, they submit the claim. So we process the claim as fast as we can. That's where we make the money. Like the sooner we process the claim, we get better margins. Working with payers who could be a Medicare, your Medi-Cal, and other government entities, as well as other payers like your insurance companies like Aetna and other payers as well. So that's sort of what Change Healthcare is in the intersection. And we process almost 1/3 of all the healthcare transactions. So almost $2 trillion worth of transactions we process all the claims. So we have a huge market share in that industry. Although it is fragmented, over years we consolidated Change Healthcare, and we currently occupy around 1/3 of that. And in addition to the healthcare network, Change Healthcare also provides a lot of software and analytics products to the healthcare companies, both the provider side as well as the payer side. So we take care of them in many different aspects as well. Like for example, capacity planning and other things. So how we are using AI? So we believe AI is the core of this whole engine. So basically we want to use, because if you look at it, all these medical records are hidden in PDF files, images, and other things. So the traditional IT has not captured those value in those things or the meanings of it. So it's all in. So AI sort of fits in right in the glove, because now I can understand the medical record or the claims, which has got the medical record of the patient as well, and then process the claim faster. How can we do that? We can automatically process the claim. So in certain areas, or practically tell them this claim will not be processed because of these reasons. Because the whole idea is we're trying to remove the feedback loop. The more feedback we have, back and forth we have, it will take up to, we are seeing claims which are sitting in our system for years. People have filed many years back and we're still trying to process it. It is a lot of work for us, for the companies, as well as they're losing a lot of revenue as well. So the whole idea is to process the claim as fast as we can by leveraging the human capital we have. So we have a lot of human agents. So we want to send the highest value claim to the correct people. So we have collected a skills of each of these analysts who work with different companies. And then AI basically magically matches that skill with the high value claims and send it to the correct people so they can start processing the claim faster on a prioritized basis, a prioritized queue. So that's one big area we're working on. In addition, we're helping the providers with telling them what are the reasons this claim will be denied. So maybe you don't have attachments. You need to add additional pieces. So we want to solve that as well. And then in addition, we are trying to automate the audit process. So there is some additional auditing happens. When you file a claim, sometimes these claims will get audited. So we want to automate that using AI and NLP. The other areas we're working on is assessing the risk of insuring a patient. So that's that's one other big thing we are doing as well as assessing risk. Like, can we insure this patient? Things like that. Also, we can understand by looking at the history of the patient and what encounters he has done, and then I can assess the risk of the patients as well. In addition, we also looking at sort of interesting things like understanding the patient itself, himself. So can I because now I have the history of what happened to this patient. I can do some interesting things with that. We're still in the exploratory state with AI because there's a lot of opportunity here because we have all the records flowing through the system. I can keep track of a knowledge base. Of course, it is all rights. We also have nice rights management. So basically, we don't expose things to only people who are given consent. Things like that. We have data rights. We use all these things as well, so that it's data rights are managed. Data lake. So we also have a data lake which manages the data rights and other things. So those are some of the interesting things we're doing in Change.
Wow, this is all totally new area to us. That's quite interesting. So actually, like a lot of people not focus on this area, which actually maybe the backbone of all the transactions, all the healthcare is here, especially insurances. And there is really not a normalized insurance in the US. I mean, that's not uniform. Everything is really depends on the company, the field to field, a lot of differences. So when you did those claims, I can say that a lot of customized claims. So how that AI is gonna work it through, because when we do the AI in other fields like MRI images, you see there is two things to train. There's a cancer or not cancer, but you have a lot to go through. Can you just describe on that a little bit?
Oh yeah. I think you're correct. There's a sparsity of data. The variance can be high. Basically, we go with a few higher level constructs. The good news is we have some higher level entities like HCC code, things like that. Using that, I can use that as an anchor and identify other things. So there's a normalized HCC code for each of these claims. Like for example, for a patient has come for certain treatment, there's a code for that. So once I recognize the entity, I can anchor on that and sort of do further processing. So it is like an ensemble of multiple types of models, and then the main one is sort of anchoring on the entity recognition with a known corpus of entities. Yeah. So that's the main area we work with. Yeah, totally. We have the same problem. We also have labeling, lack of labeling. So that's another piece. We try to look at this and sort of reverse engineer the human activity. So the human beings is already doing it. So they're already doing that activity today. So we're trying to reverse engineer. And the key piece is to add the end-to-end tooling. So it's not we can do it the first way around. So since it's an ongoing thing, how do we automate in ongoing processes to build this end-to-end solution so I can get this feedback from the user, and then that could go into the model and train it back. So it's a feedback loop we're looking at. So what we call this human augmented AI. So definitely this requires human beings to sort of, because the rules change and all the time. So we provide recommendations and the human agents sort of augment it. I think our hope is over time we can increase the productivity of the agents to a pretty high level, to a higher extent, and then once over time we can start automating that. So that's why we have a very phased approach. The first phase is typically trying to help the a human agent accelerate faster. Instead of trying to chew, let's do the automatic audit, automatic detection. Of course, we can do all this classification, beautiful things, but things change under the hood, which the algorithm cannot even know by the time, the rules have changed or the new diseases come in, new HCC code come in. So the way we did that is augment that. So there are certain areas like data service and other things imagine you have tedious 1,000-page document. So if a human being is trying to do that, he has to go back and laboriously check for each one. We are immediately using our AI, giving pointers to that. With the if we have higher confidence, we'll directly go to that. We'll split the page into different workflow. But the lower confidence, we'll show it to the agent. and the agent validates it, like annotates it and add feedback, and then that feedback comes to us, and we train the next batch. So that's the way we're relying on human augmentation for a lot of our process.
So you have a good labeling and verification process, I guess, that trains your data again and again. Is that right?
Oh yeah, I mean, I wouldn't say we already have all those things. We are in the process of building it because it is a pretty complex endeavor. We have to work with the legacy tools and other things. It's just not like a fresh plate of. I wish like we have a fresh plate because already there is tools and processes people are following. So how do we sort of latch onto that? How easily we can do it? An example I can give you is one of the. We did claims processing. There's a project we're doing called print electronics. So they have existing process which uses legacy OCR. Basically, so they faxes a bunch of forms to us. Like a lot of these things could be faxes and other things. They send us fax images. Sometimes they counterfeit. The claims form could be counterfeited. So instead of getting it from us, they can go on. That's the standard forms. They need to pay the dollar or something like that to get it. Sometimes they'll do a photocopy. During the photocopy, they'll skew it, okay, or like they can distort it and things like that. So the image we get is like our existing OCR cannot even extract the thing. There was only 18% hit rate. Other thing, 88% are going to human beings. So what we did is how can we this process evolved over time, many years. How can we use AI to augment this, without even disrupting the existing rules and other things? So the interesting thing we came up with is we did a pre-processing logic in front of it, where we take all the claims, we actually extract out, we identify the form, extract out the text, layer it onto create a new image, layer out the text onto that new image with the appropriate fields, and then pass it to the existing OCR itself. So we use deep learning and CNN for that. To extract out the form, it's a 38-layer network. CNN network we did, neural network we did that, and then extract out the form, identify the form, extract out the text, layer it onto a newer image, created a new form as though it's like and then feed it to the existing path itself. So that existing OCR is pretty smart. As long as you don't mess it up, it works well, because it's all based on fixed pixel and other things. So we're able to increase it by 50 to 60%. It was a pretty big success for us. So I mean, things like that.
Yeah, it makes.
So you mentioned earlier.
Yeah, go ahead.
Oh yeah. So you mentioned early on, Jayant, that your company really sits at that interface between the providers, the healthcare systems, trying to generate as much revenue as possible, and the healthcare insurance companies that are trying to give as little money as possible to them. So I have a question in terms of, what do you see as the current status when you have a human-based workforce that's trying to adjudicate these claims and find that balance between what the healthcare systems are claiming that they should be charging versus what the healthcare insurance companies want to pay out? And what do you see as the shift that's going to occur once AI is fully implemented? How is that going to change? Is it going to get to an optimization point? Do you think it may start favoring one side versus the other?
I mean, there's ideally we shouldn't introduce any bias. Hopefully it just does what the human being does. Hopefully that's the main. See, if you look at it, there's a huge backlog of things. Nobody's happy in this current situation because of such an inefficiency exists. You file a claim, it takes 6 months to get it back, and you might have claimed a lot more, or you might have missed some charges. So we sell both these things. So we basically sell to the providers. You might have missed. You might have not to the provider. To the providers, we might have said you might have missed some charges. Perhaps you didn't add the blood test. We recommend that as well. So we sell it as a service to the providers. Because a lot of times when they file the claim, they may not have filed all the pieces they're done to the patient because they might have forgotten some other things. That's practically that happens in a hospital where people may not file all these things for the patient. And we identify that and offer it as a service. So that's a good thing for the providers. I think for the payers, I think the good thing is it processes the claim faster for them. Sometimes they get credit from government agencies. Like, there is a provider called Centene, which basically gets most of it's a proxy for Medicare and Medicaid. So a lot of these things, like, government entities are there, which there is a lot of funds available. So you want to process the claims faster as well. It's an incentive for them to get all these things nicely so they can process the claims as well. So those are the things. I think it's a benefit for both. And also it's a huge benefit for everyone because we're speeding up the backlog. Currently, the backlog is huge. I mean, a lot of things are, like they estimated $1 trillion waste in healthcare alone, just going through this process again and again. And by just optimizing this, we eliminate the waste already in the system. And we believe everybody will be happier, like, at the final result of it, like with AI and other things, we will be happy because we can process more claims. Like, the provider will be happy because they get whatever they need, and they can get it at the start of time, and the payers will also be happy because they can leverage all the systems. So that's our belief, and the AI is definitely playing a major role in that.
And I think another interesting thing you mentioned was, especially as it pertains to medical records, when they're faxed to someone, we get a lot of faxes in our clinic from outside providers, and just like you said, we can barely read them because the font size is so small to begin with, and then the dots per pixel resolution is so low. You would have thought that with the adoption of electronic medical records, we could overcome this, but because of the lack of interoperability between the various healthcare systems, you still have to revert to the old-fashioned faxing of forms and things like that. So what are some ways do you think that either the space that you're working in or others can help you so that you can get much clearer information that can then be abstracted from the natural language processing point of view to then really take your AI to the next level?
Yeah, that's a great question. Because essentially, if you think of it, the input data, which is what you're talking about, like, the input data is very, very difficult to get, or it's like it's just a government regulation. Otherwise, people will not be sharing because it's not in the best incentive for them to share the information, because switching cost for a provider is pretty fast, and people can switch like insurance just like that. So it is in the best interest to just hold on to a lot of things. So that's the challenge everybody's faced with in this industry, and they're just doing the bare minimum to share the data, which is essentially in whatever format they just share it, dump it to the database or whatnot. That's the bare minimum. So how do we deal with that? I think there is for the images and other things. The good news is the technology has evolved pretty aggressively. Although the font sizes are low and other things, the text extract and the Google OCR we're using is phenomenal. You can get a very good accuracy. You can extract out data pretty even if you handwrite and other things. So it is coming to our rescue, the Google OCR and other things. Even if I have blurry data, it is pretty smart. And now they have optimized with the neural networks and other things. That area has evolved. So it is really helping us. So we actually use that as a cornerstone for our data processing. So we OCR this using Google OCR, and then we do some minor compensation. In addition to that, we can if we have some data, we can compensate that with our internal database as well. That's the way. For example, address. So even if I get some additional things, I can validate the address. So I can pretty much quickly compensate some of those things pretty easily. And then the healthcare records. Sometimes we have those data, so we can then compensate that. It doesn't need to be 100% clear. As long as the probability is high, we can do that as well. So those are the things we technically use to we use Google OCR as a cornerstone, and then compensate that with additional database records. So that makes it really effective. And further down the entity recognition and other things, because now I have those entities, although it's in JSON format, now I have something to work with in a normalized way, so I can then jump on it, and then we do further normalization, and then the AI can take over from there.
And so there's multiple optimization problems. So how far are you guys thinking about pushing this? For instance, are you seeing trends that surprised you that has led to new developments that you wouldn't have gone after potentially? Or for instance, are you even considering even to generate the record itself, who might not show up, or how to schedule based on previous patterns or things like that to actually kind of feed the front end of the workflow before they even start being processed?
Oh yeah, exactly. I mean, I think that's one of the things we can go up front. Like for example, I can even one of the interesting things we're doing is we're helping the doctors as they enter the data because they're entering a lot of data in the EMR systems. We can actually give them recommendations for this patient. These could be the potential things. You can just click on it and you're done. So that's one of the projects we're working on upfront all the way in the EMR because we have products which sits in the EMR which does the capacity planning of the prediction of how many days they'll be hospitalized. It's called level of care. We have an analytics platform, and using AI, we can now suddenly start reading those texts which is doctors inputting because previously it was not possible. Now I can use that and understand what type of disease it is, and then I can say, hey, this patient could be there for like 2 days versus you can discharge him tomorrow. So that's a pretty interesting use case. We push it all the way to the almost to the point of care itself, where the hospital can, the doctor can himself get optimized. The other thing we're looking at is how do we even help the patients? If I can keep track of some of these things over time, what are the procedures they've gone through and other things, then I can predict perhaps this patient might develop this thing. So those are the things, opportunities there. We have not gone into that, so we're laying the foundation for future something like that, where I can also understand the efficacy of a drug. For example, since all this data is here, I mean, what he has taken, whether he has done anything, because the follow-up visits are there. Nothing's preventing us from doing a small clinical. I mean, we can give it to anonymized data and give it to a clinical study or something like that, for the long-term efficacy of some of those things, which is a pretty difficult thing, a drug efficacy of a drug in a chronic disease, which goes on for a long time, is how it's impacting. So some of the studies you can do as well with all this historic data. So those are the things, potential is that we have been looking at some of those things. Yeah.
And I also wonder in terms of once the patient's been processed, sometimes, there's a lot of said that maybe there's something that went undiagnosed that could have been diagnosed. So are you using kind of like a combination of natural language processing and imaging or whatever other data you might find to say, maybe we should revisit this because there was a lesion on here, but you didn't mark it as a lesion or something to that effect? Is that also part of the predictive nature?
Well, I mean, see, we also work with a lot of startups, so we can't go after all those opportunities because what we are sitting is a treasure trove of data, imaging data, all those things are with us, because we have an imaging group as well. Now we can, I mean, our core area is certain areas, we invest heavily in that area, Chain Healthcare as a company, but then we partner with many startups. So startups can access those data. So we have a data platform actually, which the startup can come and say, hey, I mean, I want to get access to those data. Because a lot of startups don't have these type of multi-year, million patients data. They can work with us and get access to some of those things. And we partner with a lot of startups as well in expanding that area outside our core areas, the areas you're talking about, the correlation. I think it is possible with the data we have, but those areas, sometimes we just partner with some of the startups to do that.
Yeah, I mean, that's really so valuable, huge data there. So I remember, I mean, I thought of something like you can look at the trends in healthcare expenditures in the fields. If it goes down and up, if diagnostic models improves the system, improves the therapy or health the diagnostics, you can learn a lot from it. I mean, I can't imagine how much you can do with this data.
Yeah, exactly. I think that's why we left imagination. So we have this concept of sharing the data. I mean, of course, it's all anonymized and there is good data rights and other things there. We work with a few of the startups who can come and work with us, and we're working on offering a compute layer, so they can actually run their algorithm directly there itself. Instead of just getting access to data, they can just run their algorithm, run experimentation, things like that. So we have an AI platform we're offering to other people as well.
There are a couple of questions that we're bringing from the community here. There are two separate questions. They're kind of unrelated, but I want to pose them to you. One is asking, do you see the use of voice interfaces improving the data capture and data accuracy for records management? And the second one relates to healthcare disparities. So this person is writing that it says millions of Black people are affected by racial bias in healthcare algorithms. what is being done to reduce racial bias in healthcare algorithms. So is there a potential role for AI to be more neutral, let's say, than maybe a human adjudicator when looking at claims or assessing paperwork? That's the second question.
Yeah, I think, let me take the first question. First question, I think we also work on the conversational AI. That's one of the big pieces my team is working on, which is conversational AI, which includes chat, voice, and other things. We believe that is going to change the way patient is interacting with the hospital. So one of the big branch we have as part of Change Healthcare is we also offer the first or the second level of the back office administration for the hospital, like appointment management, things like that. So we're using now AI in conversation to automate that. So to have a better experience for the patient, they call in, instead of going to queue, now they're going to be greeted with the automated agent, or they can log into the portal and they can start typing. And the conversation, same conversation can happen in both chat and the voice. It's all going to be voice automated. We're taking it seriously, the patient care, how to improve it. Currently, it's all very manual, human capital driven. So we want to bring in AI and automate appointment and other things as well. That's a big one we are working on. For the coming back to the bias, so we want to make sure, we want to be ethically correct and other things. So we have that as one of the mandates we have is the ethical use of AI. So all of us read that and make sure we're not introducing unconscious bias and other things into the system in any way. And I think Change Healthcare is taking it very seriously in that aspect. And that's part of every project. We have a mandate for every onboarding person, data scientist. So we ethically need to make sure we're following the best practices and we're unbiased in that. So those are the things that part of the SDLC we have, software development aspect.
I think when you remove the human from the system, hopefully there won't be bias. Yeah. Unless you do the labeling with human, there will be bias if the human labels the data too.
Exactly. The humans are creating the system.
The human create system is a problem. There is a system called self-supervised learning. I don't know if you tried that models that removes the human, system supervised itself. Maybe if you choose the labeling people from different backgrounds, diverse background, it removes those factors, this bias, racial bias, and other discriminatory biases away, hopefully.
Yeah, absolutely. I think that's a great point. So we do two levels of labeling. One is we have the labelers. Some diversified companies actually deploy the label, and then our data scientists also review those labels, make sure it's correct, as well as input comes from our analysts, the human analysts who are working on it. So pretty much it's a data set which is cleansed at multiple levels. Hopefully the biases get addressed there. Yeah.
I also wonder, you mentioned labeling and you mentioned voice, what if you combine the two? It might be interesting, if it's I could think of it in a couple different ways, at least. One where, when someone actually is not doing so well, their voice actually changes. Maybe it's hoarse, maybe it sounds weaker. Maybe if you had phone call data, you could then normalize them to themselves and see, oh, maybe there's a marker, you should come to the doctor, you sound like you have a cold. I think the other use of voice, I wonder if you might consider is, you mentioned kind of the interface with the patients with, chatting or whatever, in terms of chat bots. I don't know how everyone else is, but a lot of times you call in, it's not the most pleasant experience talking to a human. So maybe it would be better if it was a bot. And, people like bots that speak in a cadence that they do. So maybe, using AI machine learning to kind of adapt a bot that would give them a pleasant experience and maybe extrapolate more information out of them. So I don't know, I'm just kind of throwing these out there since you brought in voice.
No, you're absolutely correct, because this voice interface has changed. Because even I've been using voice. I worked on a company called Nuance, which was one of the early generation, which is a Markov-based model, hidden Markov models. So they take a sample and then they use probability to determine whether it's A or something like that. They split the voice into pieces and they try to direct each word. So that world is gone. After the Siri and other neural network has come, that's one of the first things they tackled is this is a speech recognition. Speech recognition completely is new with the new neural network and other things. I mean, it's pretty fascinating. It is how it is. You can do free form text. You can just talk to it like Siri and other things. So the underlying models we use is Brett and Siri, also the Alexa model. In this case, we use AWS extensively for dialogue management. So it uses Alexa, and we also have custom model which uses Brett, which is the industry standard for recognizing these text and other things. So the concept is you just take a sample and then you convert that into text, and then we run it with this neural network. It detects this model in an iterative fashion, like using LSTM and other things. So it is much more accurate. So I can do all sort of combination, and it will derive the entity out of it. It's pretty fascinating. It is very free form, and the same thing we're using it for voice. So I can call into the same system. The IVR does almost the same thing. I wouldn't say it is quite the same level as the chat, because there is a translation layer that I think they're still working out that interface. But I think the hope is you can freeform talk to it, like as easy as Alexa, and we can grab all this information on the fly. So that's the one we're working on. I think this will give a very pleasant experience for the patients to call in. Instead of the traditional, I mean, if you look at healthcare, it's a little bit behind the curve in terms of technology adoption. So I think we're sort of delighting the customer. Like they get the same experience as calling like any other, modern startups or anything or any other things. So we want to get the same experience to our healthcare, partners as well.
Can you give us a sense of your perspective, having transitioned from various arenas, still always in the data sciences, but maybe not always in industry, kind of what your perceptions were before going into industry and now having been there? For the data science community that's the audience, what is the reality versus perception?
Yeah, I think that's a great question. I think data science itself as an industry is sort of evolving because 3-4 years back when I started heavily into the AI, a lot of these algorithms are not available. I had to hand code, like the AutoML was very clunky and all those things. And engineering practices were not integrated. It was not mainstream. It was more like a skunk project. And if it is really successful, then it goes into, except for, I'm talking about enterprises, perhaps in bigger companies, it was Facebook and other things might have been widely adopted because of the opportunity they had with data and use case they're going after. If you look at a normal company like enterprise and other things, they had the trouble of data was not there. Data consistency was not there. So they never intend to collect the data for AI purpose. AI requires a nice label set, then everything goes well. So most of these projects were all in that researchy type mode. So now it's in mainstream. In our case, it's sort of going in the last 2-3 years. It's going 2 years or so. It's gone mainstream. That means the engineering practices. So the shift for data scientists is you almost have to be like a software developer. So you have to put in all the software practices so your algorithm can operate in different circumstances and all those things. It can it's almost you have to develop like a software practices have to be there. So that's the change shift I see in the industry where the software code is not going to be a Jupyter notebook with it has to be a sort of well-tested unit of code which can run in a production grade application at scale. I mean, that's a big shift for a lot of data scientists as well. So that's one of the things we are also noticing is to take this algorithm, how can it adapt? Can it impute? It does, all those things we want to, and the accuracy also. The customers are expecting some high level of accuracy. How do you handle different variations? As well. That's another shift. The other shift I noticed is a lot of algorithms are available out of the box, like forecasting. Take an example of forecasting, which I worked on at Veritas. We have out of the box from forecasting algorithm from Facebook called FB Profit. I can use that. I mean, I don't need to invest time in building that forecasting algorithm from scratch. Same with OCR. So I have the opportunity to use a couple of cloud providers, OCR like Textract or Google OCR as well. So out of the box, the cloud provider is providing a lot of these building blocks. They also have AutoML now. So this trend is shifting towards a little bit into the engineering. Now I can use out of the box. I don't need to sort of all the time build a custom algorithm. I can start, my toolbox is expanded now considerably. So those are some of the trends we're seeing. Yeah.
And I guess,
go ahead, Ryan.
sorry. Now, you mentioned that you work, with a lot. You definitely developed a lot of platforms. You work with a lot of other smaller companies that can incorporate into your current role as well. What advice do you have for them in terms of business model? Because I think a lot of the digital health companies, before they make it to the stage where they're sustainable, it's hard for them to get access to the healthcare system because they're on a very fast innovation track oftentimes, and the healthcare ecosystem doesn't tolerate that type of innovation. So what advice in terms of how to, it always comes down to how are you going to get paid as a company so you can actually develop this? So do you have any kind of insights into how they can go about doing that based on your experience?
Yeah, absolutely. Because I work with a lot of startups in change healthcare. Because in fact, we work with Health Fidelity, Machinify, Health Buddy, many other startups. We even partner with them on a regular basis as well. So I think the biggest advantage they have, the startups they have, is this partnership with the company like Change Healthcare. Because we have treasure trove of data, we have some challenges, of course, traditional enterprises, which is legacy software, things like that, and having that partnership and is really helpful for us to accelerate our solutions, as well as they can be decoupled. For example, the systems are all at least in our case, it's all very decoupled. I can send them some data and then they can process it and send it back to us. So integration is not too heavy. Of course, it is slightly heavy, but it is, in my opinion, it's a little bit lesser than a system like CRM or anything like that. It's much more heavier, integration as well. So I think those are the opportunities I see. Also, understanding the domain is very important because these are all very deep domains. For example, you need to know, I can use the HCC code to figure out this magic of, denying a claim. So that secret sauce will only come for a person who's been in the industry, who has seen the vision. I mean, that is a very interesting partnership. So a lot of times when we work with startups, we educate them. Hey, this is our process, because this is our process. Can you help us here? We have obviously we have in-house expertise, but at the same time, we work with a lot of startups. So we tell them, hey, can you help us in this area? So that type of synergies have worked out in a lot of cases with us. Yeah.
Yeah, I like the question a lot, Ryan. I should tell you that a lot of startups, as you say, they have great models, they have great teams, but they didn't have a great data like you have. So people also ask that. They like to communicate with people. They like to collaborate. I maybe refer them to your LinkedIn page. They may ask you, or they can, if they have questions, they can ask from Magnimind that develop models as well. So you can communicate with me and Jayant and others through the maybe LinkedIn, I will say. Is that right?
Yeah, it sounds good.
Yeah. Chirag, were you saying something, or? I can tell you that there are questions in the chat and there are questions in the questions section. So it's better always to get the questions in the, sorry?
Yeah, there's one question that popped up. I'll just relay it here to Jayant. It says, you mentioned these new tools available now from Google and other providers. Are these tools accessible or available to the public? And how do you access them? The kind of ones that you mentioned are the cornerstone of some of your work.
Oh yeah, absolutely. I think I can put links to that question as well. Yeah, absolutely. These are all available in Google. If you go to the Google OCR, the one, see, the cloud vendors are providing a phenomenal, the companies like Azure, or GCP, which is the Google Cloud, and Amazon are providing this phenomenal algorithm out of the box. So you can get started pretty quickly from your perspective. Get a problem domain and start working on it, as long as you have data. So these are all publicly available. I will send you some link. And there is good OCR tools available, very good what do you call this, different types of algorithms like AutoML, there is more fancy algorithms like reinforcement learning. In fact, they have the whole framework to build you the end-to-end, feedback loop type solution. Imagination is your, is your limit, because this now modern providers provide you this whole end-to-end flow. And obviously, there is also startups who provide this end-to-end as well, Data Robot and other companies, as well. It accelerates the whole thing pretty fast. from a problem perspective. If you have a problem and you have data, then you can sort of apply this pretty rapidly. Yeah, I will definitely send some link.
Following up on that mention of the sorry, Murat, just want to quickly,
Sure.
Following up on this concept of imagination. So let's walk forward 5 or 10 years into the future. What's your vision? What's your vision for what your company does and for the healthcare system in general? What will the footprint be of AI, in this space in 5 or 10 years?
Oh yeah, I think that's a great question. So I wish like some of these things are much more automated, like, for example, like, much more seamless. Like, our hope, at least we have our own hope, is to remove the, AI to sort of take over a lot of this processing, grunt work, like, so as to say, because, and then digitizing the whole idea of people's head. Like a lot of people have this lot of logic in their head. I mean, the domain expertise. We wanted to sort of capture that and put it into the algorithm. Because that's a huge trend. I mean, so essentially take over, like, because we don't have it in data. Unlike Facebook and other companies, like all these things are changing and other things. So it's all in people's head. It's not written anywhere. So we want to capture that using algorithms. And I think over five-year time, we'll be in a great shape to automate a lot of these things, like automatically process the claims. I would say like at least 30 to 40% can be automatically processed, the claims, at least in our case, and that will be, I mean, that's a huge improvement in productivity for overall for the healthcare industry. Like you're looking at 300-400 million savings for the entire industry, and we want to be there. We want to be the big player. Hopefully, we can achieve that $1 trillion. Then we will be the big one. But I'm more realistic, and I'm thinking maybe like half of it we can capture, 500 million revenue. We want to generate that much revenue for us. What we call a hockey stick, because once we have the system in loop, it can sort of take over, and sort of go through that. So we're in the early stages of adoption of that. So we envision that to take off. And then hopefully at some point, we become the backseat. Things can move on. They can file a claim. I can switch. I can take on the patient record as well. Imagine, currently it's very difficult for a patient to get hold of the records. So I'm hoping in 3-4 years, any patient can come like a Gmail. They can open like a healthcare portal. They know what exactly happened over many years. I mean, and then we can even integrate maybe perhaps with 23andMe and things like that. So you'll see this whole, hey, what's going to happen now? What's going on? Future. Based on your genomic information, based on your reality. So you get this human portal, hopefully, which will tell you your current trend, where you're going. I mean, that's a scary thing, not for everyone to look at that. But I mean, I'm hoping somebody will come up with that type of integration.
It's really exciting.
Yeah, it's an exciting time for healthcare. Yeah.
There is one question I always was wondering about. I've been actually into blockchain technologies, but I had a hard time to figure out how that will fit in the healthcare. There are a lot of, it was trendy, it's still trendy in some way. What do you think about the blockchain, the use of that in the healthcare and especially in AI?
I think it can help. So we have the blockchain initiative in chain healthcare. So it can, it could be a micro transaction. For example, you want to process one claim, maybe that's a blockchain transaction. So that's the way we're thinking, utilizing blockchain for processing the transaction. It sort of naturally fits in, but it all depends on the adoption of the industry. Maybe instead of signing a contract with us, they can use blockchain and sort of use that, and then technology for that exact contract. So currently, each of the providers sign a lot of physical contracts with us. I mean, for the legal reasons, for the data access and other things. So that's the area we thought we can use blockchain to automate, the contract aspects as well. But it's in infancy. We're actively looking at it. So we have a division within Chain Healthcare which does that.
Speaking of blockchain, I read an article recently about the ethics, in terms of patient consent, because obviously patients go to the hospital to get treatment, not necessarily to share their data with other entities. But could there be a role for blockchain in this kind of way so that patients give consent to use their data for maybe a certain indication or a certain purpose, or even for a certain amount of time? And then obviously if newer technologies come along down the road that allow us to extract even more information from that data, that could be enabled with such an approach. So that way you feel very confident and secure in being able to use this vast array of data, which is critical for getting new knowledge, and then be able to share it with your partner so they can also kind of create new understandings of health and human disease.
Oh yeah, exactly. I think that's a great use of that's exactly where the blockchain will fit in, because the patient can basically get some value out of this whole thing. Because so currently, patients, although they're giving the data to us, like they're not getting any value out of it. I mean, we are using it to process the claims and other things. We have to use it. There is no other magic here, because we have to take the record and send it to the other people. And along the way, we're trying to find some benefit, but the patient himself is not getting any benefit at all. It's almost like social media. So I post some, some blog or something like that, you get the ad revenue. But if you are in Twitter or something like that, you're not going to get it all the time, so unless your blog reaches a certain level. But patient record is a very valuable thing. So definitely, I think that's exactly a good fit for the blockchain to come in and so that type of software, somebody has to, invest. Maybe that's the opportunity for startup to work and offer that to a company like us. So, and it has to be in the entire value chain. It has to be added to the entire value chain.
Yeah, that's great. So there is one question I like to ask everyone, that is there any application that panel thinks could negatively impact patients or is not ethical? So for example, gathering data from interaction outside of healthcare space. So do you especially we deal with all this time patient data, especially Ryan and Chirag, they know how the patient data. Do you guys have any concern about any application that would be problematic for the ethical wise? Any?
Well, I think that James, hit the head on the nail there, is that, or rather hit the nail on the head. Sorry. He said that his company by necessity has to have access to the data. That's the only way that they can review the claims and then the process is for the payers to make an adjudication whether they're going to pay out the claims. That's very different from what some healthcare systems are doing around the country, where they are selling their patients' data to other entities outside of their institution, not for the purpose of forwarding their patients' health, but rather so that they can generate revenue on this data. It is anonymized, obviously. It's respecting certain privacy laws, but I think the intent is very different there compared to what Jayant is his company is doing out of necessity for what they have. Now, at the end result is that these entities outside of the hospital and the healthcare system have access to these vast amounts of data. And I think it's critical that regardless of what the initial intent was, whether it's out of necessity or in a for-profit motive, as Jayant mentioned, the critical factors here are going to be ensuring the security and privacy of the data, that it is really shared in a very appropriate and ethical way, and that's being used at the end of the day to help drive benefits to human health, and ideally the initial patients that on whose data was provided to those external entities. But that's kind of how I would think about it, because I think it is important that we have lots of data. That's when we're going to learn a lot about population level health. But where it's coming from, how it's used, what is the intent, I think those are all relevant factors. I'm sure Ryan, given his leadership in FIND, also deals with certain similar challenges, especially like the Google baseline study and others, where you're collecting massive amounts of data. Here, the intent is obviously for research and for discovery.
Yeah, I mean, I definitely agree with everything you're saying. I mean, I think there's a lot of potential for having some negative effects, but there's also the other hand of all these positive things. Like we've discovered in multiple cases, things that would have gone undiagnosed had we not surveyed this wide body of information. So it comes down to handling the data in a responsible, secure, private, ethical way. And I think we're working on that with multiple committees, with other partnerships of just trying to protect people as much as we can. Because, I think a simple example is some of the, the genomic type of data, for instance, there's not complete protections in a policy standpoint for other types of, what are the ramifications if we can say you have this genetic profile and it may lead to this in the future for your employer and some of those. So some of these things are protected, some of them are not. But I mean, if it has the potential to save you, I think it's something that we're definitely trying to explore and mitigate the risk as much as possible. And we're exploring it by collecting as much as possible so that we can identify the minimum viable amount of data that's needed. And I think that's kind of something that the medical system tends to do in general is, as a physician, like Chirag, for instance, you're only going to be accessing the data if you absolutely need the data. And so that I think we try to think of it that way too. Can we identify, risks, strata, different modeling systems that we can identify what is really necessary and only handle it when we have to? So that's I think how we think about it.
I think that's a great point. And I think another thing that Jayant brought up at the outset was, the potential for this kind of predictive analytics for the patient, because just like you said, we have the sea of data that's so disparate. It's, in the radiology tab, the labs tab, the clinical notes. No one has time to read every single detail of every single note. But if the AI platform is able to synthesize all this information and pick up on trends or things that the patient or even their providers aren't even aware of to look out for, that would, at the end of the day, provide that direct benefit to those individual patients. So although they're sending their information to you for processing claims, they could potentially get that real big benefit for their personal health out of it. So that would be another good collateral benefit of this approach.
Yeah, that's great. So we actually came to the end of the hour, and we have a lot of questions. Unfortunately, we cannot cover all that. That's why we have that almost every week. So I'd like to thank Jay, Ryan, and Chirag for today's so insightful conversation. I'd like to thank on the behalf of everyone. Appreciate your time. Thank you.
Thanks a lot.
Nice meeting you. Thank you.
Good to meet you.
Good to meet you.
Bye.
Bye.